So let's do this. What we're going to do is we're going to dissect this application. We're just going to look at what file. So we haven't written a single file, but we got a bunch of files written for us. So I just want to explain what is what, right? Let me kind of, if you expand the project, there are a bunch of files. I just want to kind of explain the big picture, what's what. So roughly, these files here are your Java files, right? Everything under source and under gen, that's your Java files, right? Roughly, everything under res folder is your resources, right? So these are your resources. Remember how we said an APK, an application, is your Dalvik code, i.e. Java, so Java/Dalvik, right? Because Java gets compiled into Dalvik, plus your resources, and that's how you get your APK, right? That's how you make your application. That's what we said earlier on that slide, right? So that's that. This is your Java, this is your everything that's not code, i.e. a resource, and we glue them together. We zip them up together and we get the APK. There's a third file here called the manifest file, which is also going to be important, which sort of is the meta information, the high level big picture about your application. It's an XML file that explains what's what in the app. Okay? So far so good? So, and that's that R file that you guys are having problems. For now, all you need to know is the R file is basically the glue from the world of Java to the world of resources. So, and I'll explain how that glue works shortly. So let me do this. I'm going to open up these files. I'm going to open them. I'm just going to open up the ones that are significant, that we care about, and then we're going to talk about them. So you know what is what. So I'm going to start with the top file, the manifest file. So basically, what we have here is we have the manifest file. It's an XML file, like I said, that outlines the entire app. What may be confusing here is that I said it's an XML file, but it doesn't look like an XML file, right? That's because Eclipse does this thing where it tries to sort of give you a friendly view of XML files. Sometimes that's useful, sometimes it's not, right? Some people just like to dive into XML and don't need all the hand holding, but sometimes people prefer it. So as you can see, there are various tabs at the bottom of that file. You can click through the tabs and you can like adjust various parts of it, but ultimately the last tab at the bottom will open up the XML view. So this is the actual raw XML of that file, and you know, that's what it looks like. You don't need to worry too much about it right now. You know, roughly we have something called the manifest, right? Starts and stops there. And then we have something called an application inside of it, and within an application we have something called activity. That's all you kind of care about for now. And some of the bits and pieces that we entered in our dialog box when we created new projects, this is what they are. So remember, we entered the package name, that's where it goes. Remember, we entered the activity name, that's where it goes, hello Cisco. Remember, we entered the minimum SDK version, that's where it goes. Okay, those are some bits and pieces. Okay. So that's the manifest file. Now, the next file that we have is another XML file, which is called strings. So the idea behind strings XML is that you put all the quote-unquote English into that file.
Where, which folder is the strings of XML?
So it's under values. So it's right here. Yeah, resources values. Yeah, so that's that file. So basically, strings is where you put all the string values, i.e. your English. Right. So and as like I said before, the idea is you don't want to hard code it in Java. That's like not a good practice. Like for example, if you have an application name, you don't want to hard code it in Java because that makes it hard to change stuff. You would rather keep all the language stuff separate, and that's what that separate thing is. What Eclipse also does, not Eclipse, what Android also does is it gives you an easy way to provide alternate resources. In other words, you may want to translate your app into a different language. So that makes it really easy to just take this one single file, give it to the translator, have somebody translate it, and then have an alternative version of that file for that language. Okay. I'm just gonna really briefly show you how that works, but we're not gonna actually do the actual translation. It doesn't make any sense first. But for example, I may have a button, and so I'm gonna add a new string, and I'm gonna create a button, and I give it. It's a name-value pair, so I'm gonna give it a name button update, for example. That's gonna be my update button, and the value is gonna be just an English name update. Okay. You don't have to do this. This is more just kind of to demonstrate. So, there's you may notice that this doesn't quite work. Like, for example, there's no button to click on, and there's no apply button. You gotta Control S to save it. So it's kind of quirky, these tools. A lot of Eclipse tools are quirky and buggy, but the way I see it, the price is right. So if you want to complain, there's really no 1-800 number to call anyway. So such is life. But that's why often we're just gonna dive into XML because we're gonna hit limitations with this sort of hand coding tools.
If you need to support multiple languages, do we need to have a multiple string XML file, or just only one string XML file to carry all the different languages?
Yeah, you would provide, to support multiple languages, you would provide the multiple copies of strings XML file. So let me show you.
The scope of the string is for the whole app, or what is the scope of this XML file? Where are these scope of these strings that get applied?
So this the scope is the entire application. Yes. So now if I wanted to provide an alternative version of strings, for example, for another language, all it is creating another directory to put this file. Now, you may not know the convention for creating those directories, so that's where Eclipse is kind of useful. You can go File, New, and then Android XML file. And don't worry, we'll be doing this quite a few times, so you don't need to memorize it or write it down or anything like that. But we'll be using this dialog quite a bit. So, for example, if I say I want to create another strings XML file, it says, well, the destination for this file already exists, which it does. However, this time around, what I can do is I can put certain qualifiers on that file. So, for example, I can say, oh, but I want to specify a language, right? Under languages, I can, for example, go and I can now put a specific language code, and it's a two-letter language code. So, for example, if I put Mandarin, is that ZH? I think it's ZH, right? Well,
Why would everybody? Is that like a generic?
no, I'm just kind of asking.
Oh, like that.
Let's go.
Like what?
Let's use ES for Espanol, for Spanish, okay? I travel the world, so I always try to use something that's. I just got back from last week. I was in Taipei and Tokyo, so if I'm a little jet lagged, that's why. So anyway, let's say it's Spanish. So I basically just assigned. I'm creating a Spanish version of strings XML. Now you may say, you know what? Spanish is spoken in multiple places. It's not like Spanish is the same everywhere. So we can say, oh, I want to qualify the region as well. So I'm going to put MX for Mexico, right? So what that does is it basically puts this creates a directory called resources directory, but then its values and then -language -r region, right? So basically, if I was gonna click OK, finish, that would create a new strings XML in this folder, which would be applicable if user had it set to Spanish in Mexico, right? But it will not apply to Spanish in Spain. Yeah.
But let's say if Android framework already support a different kind of the language, does it automatically pick up the file or the resource or?
Yeah, it automatically, so Android is automatically going to pick the best matching resource. So if you have alternate resources and your device is set to use a specific, somehow you tell the user tells the system, hey, I am preferring Mexican version of Spanish, then this would apply, right? So this was the example of language. You see that there's a whole bunch of other qualifiers.
You
For
do time also? You do like time zones as well?
There's no time zone, but there's country code, which actually refers to three-digit country code, which I don't really, the mobile country code, I think it may be the area code.
Oh,
So 001 would be for US, Canada, Caribbean, right? And so on and so on. So
this wouldn't, so it would just pick the country code and do a time zone localization for that, you think? The time zone localization?
yeah, but the time zone is not something people localize much on because the time zone is sort of the vertical planet slice, right?
Right. Yeah, I'm just equating this to, what you do on your desktop setup maybe, and then, we set what the time zone should be, so.
Right. So, but if I know that I'm in a -8 time zone, do I really know what locale to use? Because that's both Canada, U.S., half of South America, and so on and so on, right? So that may be a little harder. But you can use any of these qualifiers. So, for example, I can say I can do a certain different type of text for different orientation. Now that doesn't really make sense. Orientation is the screen orientation, like vertical versus horizontal, right? So that may not make sense. However, if I was making not strings XML, but for example main.xml, which is a layout, then this may not make sense. Right? Like, why would it be a different layout for different language? Unless sometimes for Asian languages, because the form factor is different, right? The radicals are more square versus like flat and so on. So then actual layout of a screen does make sense to be different because the button is going to be squarey, not like boxy, right? However, it's more common for like layout stuff to do orientation. So I may have a different layout in case the screen is landscape, which is pretty common. Or you may have different layout in case the screen it doesn't have a touch screen. It's a stylus, or it's keyboard is not supported, and so on and so on. So the point is you can apply multiple versions of resources. We're not going to do it, but I just wanted to demonstrate that. So that's my button. That's my strings. The next one we have is under layouts. It's the layout. In this case, there's a file called main.xml. So I'm just going to show you what that looks like. So as you can see, it's just a big black box. I'm gonna typically turn these boxes from white on black to black on white, just because it's really hard for you guys to see what it says right there.
It's probably the projector because we can see, and we can see.
Yes, it's the projector thing. I totally know. Same thing here. So I'm gonna switch it to theme light. Now this doesn't really do anything when we run it, but for development it shows you, it flips the colors. So I usually do that to make it easier for you to see. But this is basically layout of my screen. So you can see I can have, like, for example, I can find a button here. I can drag and drop that button here, and then I could, for example, change its text to something called, for example, that button update thing that we have. So button update, bam. Don't worry about doing this because you guys we're going to be doing quite a bit of this, so don't worry about doing it in this example. This is more just to kind of FYI to demonstrate it. And then I save this file, Control S. Now, those so far what you've seen is a couple of resource files. Okay, now we're moving into Java realm, right? So the first file that I have here is a file called R that some of you are missing, right? So R is in an auto-generated folder, in a generated code folder. It's right there under gen, right? So R is automatically generated. Do not modify. So the system worries about this file and makes it for us. So something is watching everything in here, and as anything in here changes, this file automatically gets changed. And I just realized that that yeah, I have to move everything a little bit because the screen is cut off. There we go. That's better. Okay. So as I change anything in resources, R gets updated. So remember how I added the button update string? See, there's the information about that right here. Okay, so what's the purpose of R? So R is basically a set of pointers that points from the world of Java, so via R, to the world of resources. So R is just there to kind of help Java find specific resource. Okay, and as such, this file is automatically updated all the time, and you do not need to ever look at this file directly. It's just an ugly file with a bunch of pointers, so you never actually open it up and look at it again. Okay, so I'll show you how you use it. We're going to use it quite a bit, but we're not going to be staring at it. Okay, now let me show you really quickly how we use it. So finally, we have our Java file, and as I said, Java is sort of the top dog, right? This is what ultimately gets converted into Dalvik and runs, right? So this is our Java file. Remember, we said we're going to have an activity called Hello Cisco. So that's that activity, okay? And we override one of its methods, and when we override the method, we get a call super for that method. So basically, we're now back at square one. We haven't done anything in this file, right? Except line 11. So line 11 is where we do the first stuff. And that stuff here, what we're saying is, we're saying set a content view. In other words, set the view of that. Remember, activity is roughly a screen. So set the content of that screen to something called R layout main. And this is how we're using R to point to a resource. So R layout main maps to resource layout main XML. Okay, so that's what that is, right? So see how we're using the R class to glue the world of Java to the world of resources. R.layout.main. So that refers to resource layout main XML. Okay, so that's what we're going to be doing quite a bit, like that. Okay, so far so good. So now what happens, what Eclipse does for you is Eclipse automatically compiles your code whenever you hit Control S, whenever you save a file. So moment, if I type a single new line and hit Control S or hit save, everything got recompiled and repackaged and rebuilt, and it's ready to ship. Okay, the reason why that happens is because we have this enabled, build automatically. If you don't, you should have it enabled. By default, it's enabled. That's why I haven't talked about it before. Okay, so that's what tells Eclipse build automatically. Now, once in a while, in some of your computers, when you initially you have a little red X here, right? Something was missing. Like you guys had the little red X, I think, here, and then it goes into here, and then ultimately it goes into here, and so on, right? So that's because your R was missing or something else went wrong. One of the easiest, if things don't make sense why it's missing, one of the easiest first fixes to do is to go project clean and tell Eclipse to delete everything that it built. And that's going to cause the build automatically to kick in again and rebuild it. So that's essentially doing make, clean, make. Okay, so you would say clean, bam, and just recleans it, recreates it, and redoes everything. So try that as a first easiest fix if the error doesn't make a lot of sense. So far so good? Yeah. So what we're going to do next is we're going to run this. App. Before we run it, I just want to show you what this app looks like on a file system. So if I go into my file system, and in this case it's in so Hello Cisco, and I go into, so this is what my my project looks on the file system. And the directories are mostly the same. You've seen most of them. There's one directory that you haven't seen in Eclipse, and that's the bin directory, because Eclipse keeps bin directory hidden from us, right? But what I just wanted to point out is kind of to demystify the magic, right? So what happens when you hit Control S is all our Java gets compiled. So here's our Java compiled. So com, Cisco, hello, and then here's our hello Cisco class and all the R class and inner classes, right? So this is basically our Java compiled, right? Now the Java that got compiled, right, gets, remember, recompiled once again into the DEX file or Dalvik executable, and that file is right here. It's this file called classes.dex. So basically this gets recompiled using DX compiler into classes.dex. Okay, so this was compiled using Java C, right? Now all the resources, everything that we had in the RES folder, so everything that we had in this folder got quote-unquote compiled into this file here called resources._ap_. Okay? So resources ap_ is essentially a zip file of all your resources. Okay? So that's why R is essentially a pointer to a location in that file. So remember what we said is you take Dalvik executable and you take your resources and you plus them, and that's how you get the APK file, right? So APK is your final shippable. It is what you put on the device, right? That's what you put on the store and charge 19 cents for or whatever, right? Right. We'll work on jacking up the price higher, but but that's basically the ultimate shippable for the app. So far so good.
So the com.cisco.hello word, it will not be in the final package because it's immediately it's a temporary file.
Yeah. So the Java file is not. Yeah. Yeah. Okay. So now when we have all that, we're ready to run it. So to run it, we need a device to run it on. Now, did you guys bring your phones? No?
We just looked at phone for the class, free phone.
You would have handed out.
Yeah. Where are your CSs? So we can run it on a physical device, or we can run it on an emulator. So what we're going to do is we're going to use an emulator, but I'll explain the differences and all that. So before I do that, let's start the emulator first, because I want to explain it while it's booting. So to create the emulator, click on the little tool here. It looks like a little Android with a...
Just a question before that. The bin process, do you have a Maven setup for this?
I'm sorry?
Do you have a Maven setup for this bin process?
Maven for...
For building this Android, instead of the Eclipse plugin, if you want to integrate it with our bin process.
If you don't want to use Eclipse.
Yeah.
Okay, so let me do that. Let's talk about that really briefly. So if you do not want to use Eclipse, like you don't like Eclipse, for many reasons. So you open up your terminal, you go into your code where your project is, and let me adjust so that it fits on the projector. So I'm gonna cd into hello Cisco, okay, that project. Now I can use a tool called Android, which is basically, it's funny, it's the same tool that we're gonna start by clicking on this button later on, okay? But it's a command line tool called Android. So I can type Android, and by the way, you can only type it if you added your tools directory to your path. If you didn't, then you need to type in the full path to your tools directory. And I can say Android create project, etc., but in this case I already have a project that I created using Eclipse. I would rather want to update it so it works for something like Ant specifically. We're not going to use Maven, but Ant, right? So what I'm going to do is I'm going to say Android update project, and then I say the name of the project is hello Cisco, and the path is the current working directory, right? And you go ahead with that. And what does this is it analyzes the project and it figures what's missing in the project to make it command lineable, to make it work on a command line. And the only thing that's missing is the build XML. That's for Apache End. Okay, so you guys familiar with Apache End? It's like the make file for what make file is to make. That's what build.xml is to end. Okay, and now I can say end install, for example. And what this does is it builds my entire project, creates it, and compiles it and pushes it onto the device and everything, right?
Where do you push it on to?
Well, I have an error, device not found, which is because we don't have a device yet. But that's, you know, I can just say and debug, that would just build it. And debug means build a debuggable release, meaning signing with the debug key. So now this build was successful. Okay, so that's how you would do it on a command line, and then you don't need Eclipse at all. Yeah.
I'm sorry, what was the full command? Android update.
It was this Android update project. So let me show you where you would find it. Okay, so if you go to everything Android starts at d.android.com. That's the most important place for you to memorize, developerandroid.com or d.android.com. And if you go under, is it dev guide? Dev guide. Oh, by the way, did you guys see that
Something had 2.3.
2.3 just got released?
Yeah, it was there only this morning. I didn't see that.
Yeah. Cool. So that's just got released, like literally just now. So cool. Something to look.
Is the same version, the API?
Hmm?
Is the API the same version for this?
No, it's going to be 9, right? So it's going to be API level 9, and I'll show you how we can download it as well. So, but Dev Guide has developing in other IDs, and that gives you all those steps: how to create a project command line, how to update a project, you know, and so on and so on. But it's right there in other IDs under the Android.com Dev Guide. Okay, so it's easy to find, in other words. So back to this. So what we want to do now is we want to create an AVD, Android virtual device, on which to run. Okay. So I could type in Android on the command line, type enter. That would pop up the same window as if I go into Eclipse and click on the little Android here. Okay. I'm gonna delete the one that I already have. So far, so good. Right. So you guys get a window.
What do you do? You click on that,
I click on the little guy right here. So now under virtual devices, you guys who are using virtual machine, you have a phone called My Phone, right? If you don't have it, if you don't have a device, you would click on New, and we're creating an AVD or Android virtual device. So I'll put a name, My Phone, for it, and then I pick a target. In other words, I'm saying what is installed on this device. Okay, so I'm gonna say it's Android 2.2, and again the target is the union of my platforms and add-ons, right? So, yeah, go ahead. So I'm gonna type in Android 2.2, and then it's asking me for a size of the SD card. It's expected that these devices have an SD card, so I'm gonna put a some size like 10 megabytes. Minimum is 8, so you just want to have some external storage. And then it's asking for the skin. Remember, the skin is what is the look and feel of the device. How big is it? Does it have a keyboard? Yada yada. So I'm gonna go with what's the one that I usually use? W. Yeah. Yeah. Which one? The Q or the? Let me see. Is it a Q? WQVGA 400? No, it's not the one.
Yeah, I think it's the HVGA. There's a typical one.
This one. Oh, HVGA. That's a 160 dpi. I'm gonna use this one because it gets pretty big. It's pretty dense. So WVGA 800. But you know, you can also specify your own resolution and adjust it, right? So whatever works for you.
About the SD size, is a resource for the application or what? Or for the virtual machine? The name of the package.
It's going to be for this particular device. In other words, for the virtual machine, right? Which the emulator runs on.
So how about for the real physical phone? Do we need to define this?
No. So we are creating a virtual device here. Yeah. So for the physical phone, you would just order an SD card on Amazon and then open up the phone and plug it in. Right? It'd be a physical card, in other words. But here we're faking it by putting a certain size in there.
So every device on the market needs to come with an SD card of some minimum value.
Every device on the market should come with an SD card. It may not, and you certainly don't have to have an SD card. However, you're going to have a mount point for the SD card. So it's highly expected the device has an SD card. It's just that there could be nothing mounted on it or equivalent of having a full SD card.
The device come with the flash. Let's say for support the external SD card. Is that possible?
Is
Say
it?
the phone come with the flash?
Yeah, it could be just that it's built in. It doesn't really matter, but we're expecting to have a mass storage on a mount point called /SD card.
I see. What does this store?
Hmm?
What's the content of store? How does it use the SD card?
So I'll talk about the file systems, but SD card is basically a free-for-all mass storage. So it's really it's not very organized.
So why do I have to specify that?
You don't have to have it, but if we are creating a virtual device,
Okay.
and it's an opportunity for us to say, does it have an external memory and how big is it?
But my app is not going to need it or use it. So why would I specify?
Maybe your app is or is not going to need it. Yes, it doesn't really matter. We're creating a device on which we're testing our app. So, you know, yes, I mean, you can say, oh, I have a phone, but do you really need to go out of your way and actually yank out a card? Not really, yeah. So might as well put something, because we may or may not want to put something on it. Our app is not going to need it, but we're going to be doing, for example, some profiling of our app. And those tools are going to need to output a whole bunch of data. So that's why I usually, do include some size there.
So in this context, when you choose file, what does it do?
Oh, when you choose a file, then you can browse to a file to make it an SD card. How would I then create a file that represents an SD card? There's a tool that again comes with your tools directory. It's called MKSD card, and you can specify the. I think it goes like I could do SD card.img and then the size 10M. That would create an equivalent image for that. That size of an SD card, and then I can point to it. So the usefulness of pointing to a file versus building it into the AVD is maybe I have 5-6 different phones on which I'm testing my app, and maybe my test data is on the same shared SD card. That's one example where I would, for example, use that as opposed to just building it into it.
So if you don't specify any I guess, storage capacity, then it's assumed that it have nothing.
Yeah, exactly.
If you try to write something, it'll crash at that point.
Yeah, exactly. It would still have the mount point.
Mm-hmm.
The mount point is always there, just nothing is mounted on it. It's kind of equivalent of having a full card with no space on it.
So if you point a file, does a physical device also read from it? Like I test on emulator, then
No.
read it and
No, a physical device is going to point to a
always
physical
point to
card,
it.
yeah. You can also specify some other hardware constraints. You can, for example, specify if SD card is supported or not, D-pad supported or not, accelerometer, trackball, camera, battery, GPS, etc., etc. So you can put some constraints on the hardware, right? So when you're done, you click Create, and now you have a device. And then what I'm going to do is I'm going to start it. I'm going to scale mine to 11 inches so that it actually fits on the screen. So you start it, and now what that's it's creating the emulator for this device. So this is what that is. And the way this looks and feels is driven by the skin that we picked. So you guys may have no keyboard or have keyboard, large screen, rectangular, square screen. It doesn't really matter. It's going to be driven by whatever you chose as the skin. Okay. So while this is happening, let me kind of talk a little bit about the emulator. So first of all, do you guys get the difference between an emulator and a simulator? What's the difference between an emulator and a simulator?
Only runs
Simulator has their own OS and those kind of thing. It's a complete system, right? Simulator probably you really have to something like people will discuss the simulator or the hardware or those or whatever.
Yeah, essentially simulator simulates behavior of some code, but emulator actually emulates the virtual machine, the machine. So it's a much lower level. It actually emulates the low-level hardware. In other words, what we are running on this emulator is exactly the same code base as we are running on the physical device. So it's compiled for ARM, it's ARM code, it's designed for ARM chipset, etc., etc. It's not like we're simulating its behavior like certain platforms do, like I think BlackBerry does that, right? We're actually emulating it. And Android uses a third-party system called QEMU, which is basically a virtualization machine, open source project, and that's what's being used for emulating the actual device.
You specify for ARM or what we're using is
It can use different. For example, ARM is a good example, but it can. Yeah, I believe it can virtualize different stuff.
Yeah, even Paul PC now and stuff.
Yeah, yeah.
We should not need to worry about the big issue, right?
Yeah, no.
Not for the Android and
Yeah, so that's why it's a much closer approximation of actual physical device. So that's why for the most part we're agnostic to if in fact we're running on emulator or physical phone. Okay. So by now it should be loaded, so there's my device.
So if it doesn't show up, should we tell me something?
What do you mean by it doesn't show up?
Click on start and it will be clear.
Does it just keep looping in the animation? Yeah, that's that could be a problem. Why don't you delete that AVD and create a new one?
What did you change the languages? Change some language. On the AVD you changed some.
When I started, I have the opportunity to scale it up because the size of this is slightly bigger than my resolution that I have with this projector. So I just scaled it down a little bit. I think it's going to be about 13 inches or whatever. It doesn't fit on my screen. And partially why it doesn't fit is the density of the screen is very different. So this is we're using 240 dpi on this particular screen versus 72 or on my monitor. Okay, so so does everyone have the emulator up and running?
How can you edit the properties once you get this AVD? Can you edit the properties?
Yes. So let me show you where emulator stuff is stored. So I'm gonna cd. Oops. Let me make this fit on the screen again. There. So if you go to your home directory, you can cd to a folder called .android. So it's it's a hidden folder. It's going to be .android both on Windows and Mac and Linux, right? So it's off of your home directory. Inside of this folder, there's another folder called .avd, stands for Android Virtual Device, and inside of there's my phone. Right? So if I cat the myphone9i file, you basically it tells you what target it was flashed with, right? and it tells you what the actual data is. Oops, right there. So now if I CD into my phone AVD, this is where the actual files are. Okay, so remember that SD card image that we created, there it is, the 10 megabyte image, right? Remember the user data that I said is very specific to each user? That's where that is. Okay. Then there's some cache directory. But where's the system IMG? Remember I said system IMG is one of the most important ones. Where is it?
Are we going to reference it from the platform, the installation directory?
Yeah, exactly, because it doesn't change. It's read-only actually. So that's referenced by in this config file, and this is where the data is for that particular emulator. So yes, you can change data here.
Through Eclipse?
You can change it through Notepad. Eclipse doesn't. Well, does Eclipse give you a nice way? No, it just says the details. You can view it. Yeah. Hmm? I don't know, but it doesn't allow me to repair. Yeah. So, but it's just you can basically open it that way. By the way, this is the same tool as Android, as I said. So if I click on available packages, let's see if version 9 is available. More. So, I need to install. Hold on. Anyway, there's some. I need to install something else first before I can even see 9. But I still don't see the SDK, the Android 9, the 2.
Want us to install this in the class?
No, don't worry about it. I was trying to show you, but it's not. It doesn't seem to show yet. So don't worry about that. I don't even know quite what's new in 2.3, a lot, or what we care. So it just got released.
So by the time this gets pushed out by the carriers to the market, it'll probably take 4 or 5 months.
It really depends. I mean, I have a very consumer device. It's just a T-Mobile running on a Samsung Galaxy, and I still don't have 2.2. So it's still, they haven't pushed it out yet. Now that I think, so that's sort of how that works, unfortunately.
So
So the HTC phones just have to go
Well, it depends. Yeah. So yeah, I think a lot of them have 2.2, right? It depends.
So based on your recommendation, which conjunction is best for the developer?
For development,
Yeah.
well, we tend to know most about HTC ones, specifically the ones that Google uses for development, such as Nexus 1 and Dev 1. So Dev 1, Dev 2, Nexus 1, right? So this is Dev 2 phone. I don't have the Nexus 1 with me, but yeah, those tend to be the best documented, the most open, and so on.
It's more open, right?
Yeah. So. Okay, so now when we have all this ready, you you can run it. Let me see what install packages. Does it show? So see, API level 9 still doesn't show for me, right? Although it says that it's available. Oh well. Oh, sorry, that's installed, available. Let's see.
Push it to the repository.
Yeah, well, it's not. Yeah, it doesn't seem to be in the repository. Found 8. Yeah, so it just found 8. But anyway, not as big of a deal. So let's click. Now we want to run this. So to run it, I can right-click on my project and say Run as Android application. Bam. And this now pushes it to the device, and ultimately it should start on the device. There it is, hello Cisco, and it's got a little button, and you can click on it. It doesn't do anything.
When you say run
So you can right click and say Run as Android application, Or you can also just click on the little run button here and say run as Android application. And that actually runs it. Starts it and runs it. So far so good?
What is,
Go ahead.
what is ADB? When I click on run, I get a lot of these messages. It says ADB is running normally and all this kind of stuff.
Yeah, ADB stands for Android Device Bridge. And that's what we use to bridge between the actual physical, your developing environment and the actual device. Now, ADB is agnostic also to the fact if it's a physical or emulated device. So let me just kind of show you really briefly. So if I go on a command line and I type ADB shell, okay, what this does is it now bridges my Mac to my command ADB shell. ADB. So, so what just happened to my SDK tools? I have that directory, right? ls. Huh. Huh. Well, that's why I don't do updates in the class. So ADB just went missing.
You have to restart the Android thing and do the third party install.
Alright, so let's see. Which third party install?
Available package, and then Android device name. The Android device name. The top one.
This one?
Yeah, and then it have 9 point something in there now.
So I don't need third party, right?
No.
Yeah, I don't need third party. It's interesting that Samsung actually push stuff for tab out. That's the first time I see somebody other than Google actually pushing something out, which is kind of cool. And SDK tool. So this is the one I need, but I don't really need the other platforms. So I'm gonna kind of, in the interest of time, I'm gonna disable all this and documentation. I'm just gonna install this. But basically, something changed in terms of how ADB is packaged. So it's,
There's a thing of code.
yeah, it just disappeared on me. So anyway, looks like it's gonna take some time to install, to download. But if you type ADB shell, it connects to the shell and it just uses it.
Yeah, you said it means ADB means Android one?
Android Device Bridge. Yeah, so it's the bridge that bridges multiple your device and this.
What would I do from that shell?
What would you do from a command line?
From the Android
Device bridge.
shell.
So ADB does a lot of stuff. It lets you access your device in different ways. So you can think of it as both Telnet, SSH, FTP, and blah 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 for your device. So you can install new software using ADB. You can log into the shell of the device using ADB. You can move files between your device and your laptop using ADB. So there's a lot of that stuff. Right. So all of those.
Question was downloading. Like Android is supposed to be an open platform and so on. How is it that like Motorola when Droid X, they put some fuse on there that if you try to jailbreak it, it break your phone or restore back to your thing?
Yeah. So third-party manufacturers, they can you can do whatever you want to the derivative of Android, right? So you can derive the platform and you can then make changes. So like for example, CS may not allow third party to install anything, so they can just like yank out the part of the system or modify how it works, the part of the system that allows installation of applications. DoD, for example, may yank out the radio and replace it with the encrypted version of radio or something. I work with companies that take out a lot of features just because they don't want to make it available at all. So the question is really then, is it an Android compatible device or not? Motorola specifically had that issue with, they released a device which was basically a scaled down version of Android, and they marketed it as an Android device, and then it sort of backfired with the user community.
Because I know I had the Droid X, and that was one of the reasons I got it, because it was nice and I would be able to do anything I wanted with it, but then I could push the application on it. And then people say we try to jailbreak it, you might break it.
Yeah. Yeah, that's you usually can then update it, but yeah, that's what they do to prevent it. So let me see if I have the ADB. No. Okay, so ADB kill server succeeded. Android SDK, Mac, LS, CD tools, LS. So let's see really briefly what changed, what we have now in the SDK. Platforms 9. So tools. Aha. That's where it is. So there's a new directory called platform tools. Okay. I guess that's interesting. So there's tools directory is still there, but then there's platform tools, and that's where ADB is. And I'm not quite sure why, but what I'm going to do is I'm going to VI my bash.bash rc or profile, and that's my path, and that's where my tools are. So basically I need to add this directory, so like this, and then it becomes platform-tools, right? But don't do this. I mean, don't update to 9. They changed more than I hoped they would. So if I kill this, Control C, kill it, restart it, path. So the env. So now my path does have platforms tools. ADB is there. ADB shell now works. Okay. So let me readjust the window size so you can actually see. But now, yeah, so they changed the locations, and I wasn't aware of this. So, but now when I do ADB shell, and you guys don't do update to 9, and you have ADB shell just working fine. You can now do, for example, PS, and I can look at what's running inside of the device and so on. Make sense? So, so that is that's that in terms of the.
So this shell system is a Linux shell or is it different?
The what?
This shell, the shell command is similar to the Linux shell?
Yeah, so the shell that I'm in right now is the shell to device. It's a Linux shell, but in terms of the commands that you have, it's very scaled down. So you only.
PC box or smaller PC box, those kind of
Yeah, it's something called toolbox. So it's not like BusyBox. It's very scaled down. For example, I don't have, you have your chmod, ls, mkdir, that sort of stuff, but you do not have vi, you do not have grep, you do not have less, and things like that.
Can I launch the software from the shell?
Yes. Yeah, you can launch
I
some.
can launch in the background also, right?
Yes.
Can
Yeah.
I do the PS and Q and those kind of
Yeah, I can do ls out there. It's running in the background, and it's done.
And I can create a file system of
Yes.
swap space, those kind of things.
Yes. Just keep in mind that right now I'm logged in the shell of an emulator, and I happen to run as a super user, as a root user. If I wanted to connect to, and I said we're pretty much agnostic to physical versus emulator. So this is just a stock phone with a stock Android. This is running just regular Android stuff from an open source project. So if I connect it into my USB, and I now do ADB shell, it's going to say more than one possible device, so it doesn't know which one to connect to. So you can do one of the two things. You can do, well, let's do ADB devices, and it shows me all the available devices. So this is my emulator, and this is my physical phone. So I can do ADB-S and specify the serial number of the phone, which is this, right? Okay, and then do shell. That would work. But if you're too lazy to do that, easier is just to do ADB-D for device or -E for emulator. That's if you have one of each. Serial number only matters if you have actually multiple emulators or multiple physical phones, which you may. So then you can, but you can have a universe of a lot of different devices connected all at once. So I'll just do -D shell, and now I'm in the shell of my physical phone. I can see PS, and these are, for example, processes running on this thing right now.
Do you need to have a jailbreak for your phone in order to do that?
No, you do not need to jailbreak it. So this one is a consumer phone, so it's just a regular phone. And now, however, my shell is running as an underprivileged user, so you can only do so much to it. So let me see. If I do ADB devices, first of all, you don't see it. The reason why I don't see it is because I haven't enabled the device to be seen. So what you need to do, what I'm going to do, I'm going to show you what to do on an emulator because you can see it, but it's the same stuff that I'm going to do on a device. So you would go to your system settings, right? And then you would go into applications, okay? And then you would go into development, and then you need to enable USB debugging. So I'm going to do that here on this phone now. So settings, oops, applications, debugging, development, and then enable USB debugging. I actually have to enable it while it's not connected. Interesting. So now I am basically connected to that phone. So under devices, notice that my Galaxy shows up as well. And now what I can do is I can say ADB-S and oops, shell. Okay, and now I'm connected to Galaxy, totally different set of applications. Right.
Show again,
Yeah, can you skip to the settings?
Oh, so okay, yeah, sure. So you go into settings. First, go into applications. You got it?
It's very slowly.
You're running inside of a virtual machine? Yeah, I don't know. And then you go under development, so application development, and then USB debugging. Got it? So that's what you need to do to enable it. So now, now, for example, if I was going to click on run, notice that it would ask me, okay, on which phone? See how I have 3 different devices now in my list, right? So is everyone pretty good now? Everyone had it running? You have the little application. It doesn't do much, but it runs, right? So we talked about how to start a new project, what important things are. We talked a little bit about what an anatomy of an app is, like we dissected it, right? So same things for any other application. You're gonna have the same bits and pieces, just more of those, right? We talked briefly about the manifest file, about what the layout resource looks like, or what the Java file looks like. We ran it. And that's about it, right, in terms of the emulator and all that. So far, so good. So let's then do a lunch, and then we're going to continue with this new section, main building blocks.